Welcome everybody. Let's take a look at chapter 9, section 2, converting angles to and from degrees and radians. We've talked a lot about our unit circle. Unit circle has a radius equal to, if you said 1, you are correct. So, this is 1, this is 1, 1, 1. Even here, the radius is 1. How many degrees are in a complete circle? If we start here at 0, we go all the way around. Well, we've traveled 360 degrees. But what's the distance around a circle? Well, that goes back to geometry. In geometry, you had a formula for circumference. Circumference is the distance around a circle. And that formula was 2 times pi times the radius. Seeing how our radius is equal to 1, I'll plug in 1. 2 times 1 is 2 times pi. That means the distance around is 2 pi. But we also said that the distance around was 360 degrees. Let's see if we can make that connection. Since the circle is 360 degrees all the way around, and the circumference is 2 pi, then for this unit circle with a radius of 1, we can convert from degrees to radians. The key is understanding that 360 degrees is the distance around that circle as far as degrees go. And 2 pi, well, that's how far it is in radians. So we have 360 degrees, that's equal to 2 pi radians. (360 degrees is the same thing as saying 2 pi radians. How far is that angle? It's 2 pi. 2 pi radians. It's a different type of measurement for angles. Using that information, what we can do is then change things from degrees into radians and back and forth. So why would we care? Why would we bother? Well, they have their uses. Radians are used a lot in higher math. In pre-calculus, we use them a lot. Sometimes you use them in geometry, engineering, different sciences. So let's do some changing here. 360 degrees, we just said, was 2 pi radians. This is a full circle. This is a full circle in radians. So if we're talking a full circle, what would half a circle be? Well, half of 360 is 180. Half of 2 pi would simply be 1 pi, or pi. What's half of 180? Well, that's 90. So can we take half of pi? We'll get pi over 2. Well, what's half of 90? Right, here's your 90. What's half? If you're saying 45, you're right. Oh, so we'll skip 60 and come back to it. Half of 90 is 45. Half of pi over 2. Half of pi over 2. So pi over 2, and then we need half of it. That would be pi over 4. How about 60? Well, to get 60, let's go back a step to here. 180 degrees is pi. That is really kind of the key to understanding all of this. 180 degrees is the same thing as pi. 2 times 180 is 360. 180 divided by 2 is 90. 180 divided by 4 is 45. What do I have to divide 180 by to get 60? If you're not sure, try it on your calculator. 180 divided by 2 is 90. 180 divided by 3 is, 180 divided by 4 is, 180 divided by 5 is. Let me know when you find 60 degrees. 180 divided by, 3. So therefore we have pi divided by 3. Pi over 3 radians is the same thing as 60 degrees. Well, if we take our 180, what would we divide by to get 30 degrees? 180 divided by 2, 3, 4, 5, 6, 8. Who do we appreciate? 180 divided by 6 is 30. Therefore, pi divided by 6, 180 divided by 6 gives us our 30 degrees. We're going to go from radians to degrees. It's often easy just to plug in 180 wherever the pi is. Why can we do it? Because pi is 180 degrees. Pi is 180 degrees. Draw approximations of the following. A 30-degree angle. Ooh, 30 degrees is cold. 90-degree angle. Oh, look at that. She's got the beach, ocean. Looks beautiful. 180 degrees. Ooh, sizzling. And her brother says, I like the extra touches. She's like, what extra touches? Jason and his friend are sitting there. 135 degrees, -1. 60 degrees, radical 3. 90 degrees, undefined. And his brother comes up. So what are you nerds up to? Just working on our tans. Get it? Sine, cosine, tangent. Marcus is like, want to switch things around and try some arctans? I'll say no because we haven't done those yet. So what exactly is pi, right? We talked about how we've got our circumference, which is 2 pi r. We talked about how 2 radii, if you want to get fancy, radius and a radius make a diameter. So we could say that the distance around is pi times the diameter. If I solve this equation for pi, that means I would divide by d. Divide by d. D's cancel, and it leaves me pi is the circumference divided by the diameter. If you take any circle and you measure the distance around and you divide it by the distance through the middle across, you'll get 3.14159. If we could take this and unroll it, well, that's kind of what we would get here. Unroll it. Our goal to be able to switch from radians to degrees and back again, keeping in mind that 180 degrees is pi. The quickest, easiest way to switch is to simply take 180, plug it in for pi. So wherever there's a pi, I'm going to write 180 degrees. Divide by 2 tells me that pi over 2 is 90 degrees. 5 pi over 4, well, let's plug in 180 degrees wherever there's a pi. We put this into a calculator. 5 times 180, divide by 4. Well, let's see. 180 divided by 4 would be 45 times 5. So I'm going to go with 225 degrees. You try. Pause, try 2 pi over 3, come back and check it in a minute. All right, welcome back. Let's take 180, plug it in for pi. So 180 divided by 3 is 60 times 2, I got 120 degrees. All right, you should be able to change from radians to degrees. Our other goal, though, is to change from degrees to radians, and that's a little bit more complicated. Yes, 180 degrees is still pi radians, but we need a way to convert these. So if I could use this little equation that says degrees out of 180 equals radians, not radius, but radians out of pi radians, so we have degrees, degrees, radians, radians, I could cross multiply to find my answer. Let's fill in our degrees. 30 over 180. The 2 degrees cancel out. R, I don't know, over pi. And then we'll cross multiply. 180 times r would be 180r. 30 times pi would be 30 pi. How do we solve for r? Let's divide by 180. Divide by 180. So r is equal to 30 pi over 180. And we're going to do a little simplifying and reducing here. We'll do it first without a calculator, then we'll do it with a calculator so that you're good both ways. If numbers both end in 0, you're allowed to cross off the zeros. It's like dividing everything by 10. So now we get r is 3 pi over 18. And you start asking yourself, does 3 really divide evenly into 18? If you're not sure, on your calculator, 18 divided by 3. 3 divides evenly into 18 6 times. So this is pi over 6. And if you're like, whoa, wait a minute, I ain't doing, okay, fine. Let's grab our calculator and let's go back to where we're right here, where we have 30 pi over 180. I'm not going to put the pi in the calculator, but I am going to make good use of that ABC button to reduce and simplify. So 30 ABC 180 gives me 1 pi over 6, or just pi over 6. You have to remember to put the pi back into your answer. This will give you the fraction, but you got to have the pi with it. 1 pi, or just pi, over 6. All right, our next one. 10 degrees. It would be kind of chilly, 10 degrees. 10 degrees over 180 degrees equals pi. Don't you hate when you your hand doesn't keep up with your mouth? R over pi. Cross multiply. 10 times pi. 180 times r. Little degree symbols cancel with each other. Degrees over degrees cancel out. So 180r, that seems familiar, equals 10 pi. What's next? Divide by 180, divide by 180. So 180's cancel, r equals 10 pi over 180. If you want to try and cancel without a calculator, great. Otherwise, I would recommend maybe you do 10 ABC 180 and reduce it. 10 ABC 180, I get 1 over 18. My answer, 1 pi, or just pi, over 18. Let's check it. You know how I always love to check things, right? Pi is how many degrees? Pi. 180? Okay, so let's check our answer. 180 divided by 18 is 10. 180 for this one divided by 6. 30 degrees. Okay? 180 divided by 6 is 30. 180 divided by 18 is 10. So it's a quick, easy way for you to check and make sure you did it correct. How about you pause, try for a minute, 135 degrees, try it out. All right, welcome back. Let's try 135 degrees, make sure you're on the right track. We'll take 135 degrees out of 180 degrees equals r over pi, radians over pi radians. The degree symbols cancel, and I want to cross multiply. 180r, gee, that seems familiar, equals 135 pi. Divide by 180. This is where you're going to want to use your calculators, your ABC button. 135 ABC 180. I got 3 over 4. So my number of radians is 3 pi over 4. Remember, you have to put the pi back into your answer. Your calculator will not do that for you, and simplify it. To check, 3 times, how much is pi? 180. 3 times 180 divided by 4. 3 times 180 divided by 4. I got 135 degrees back. You and your group take about 15-20 minutes to work on the radians. Give it your best shot. Then you guys are going to make a unit circle paper plate. You'll take a paper plate and you're going to start by folding it in half. So here's our plate. We'll fold it in half. To make our X, fold it in half again to make our Y. I would take a magic marker and a ruler, and I would draw X and Y, label them nice and dark with a marker. Once you do that, take a marker, label 0, 90, 180, 270 in one color. Now, we're going to label 30, 45, and 60, and we'll use different colors. But this is what we got so far. How do we get 45? Well, you take your plate that's folded into quarters, right? This is your 90 degrees that we made. Fold it in half, you'll get your 45s. So, there's a 45. You've got your X and Y in one color. I would suggest you draw your 45s, the diagonals, in a different color. Label that 45, 135. I forget what this one is here and this one is here, but you'll figure it out. Okay? Then you need your 30s and 60s. Alright, so I'm back to having my 90 degrees, my quarter. How do I get 30 and 60? Take your little plate, fold it into equal pieces, so that way you've got thirds, right? Fold it here, and then fold this one so it fits over top of the other one. That will make lines for 30s and 60s. I would draw the 30s in one color, the 60s in another color. Draw those lines in place. By the time you're done, you're gonna have a lot of different lines on your paper plate. Hopefully you label your 30, 45s, and 60s. Now label everything in radians in a different color. How many radians, how many radians, how many radians, radians, right? And then, for the last bit, label the angle values in different colors. The angle values are things like 1, 0, 0, 1. Remember those? 1, 2, 3, 1, 2, 3. Remember all that? Don't forget to put your names on the back of the paper plate before you turn it in. Hope you guys have a great day. Bye.